vibrations are observed in the first peak region from 4,000 to 2,500 cm-1, and what bonds are involved in these vibrations? Why do X, H stretching vibrations, where X represents O, N, C, and S, appear in this region, and how do they relate to O, H, N, H, and C, H bonds? In the second peak region, between 2,500 and 2,000 cm-1, what kinds of bond stretching vibrations are observed, and how do they correspond to triple bonds and cumulative double bonds like C is identical to C dash? C is identical to N equals C equals O, and N equals C equals S? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What is the significance of these functional group vibrations in this region, and why do they interfere little with each other, making them easy to identify? In the third peak region, from 2,000 to 1,500 cm-1, what types of bond stretching vibrations are observed, and which bonds are included in this range, such as C equals O, C equals C, C equals N, N equals O, and N, H bonds? What do these vibrations indicate about the structure of the material, and why is this region significant for identifying double bonds in organic compounds? In the fourth peak region, from 1,500 to 600 cm-1, what types of vibrations occur, and which specific bonds are involved in the stretching vibrations of X, C, and X, O bonds? How does this region contribute to the overall understanding of the material's molecular structure, and why is it important in the analysis of the organic ligand components of Prussian blue and its analogs? What happens when a transparent sample is irradiated with monochromatic light, and how does the light interact with the sample? Why is most of the light transmitted through the sample, and what happens to the small portion of the light that is not transmitted? How is the scattered light distributed in relation to the sample, and in what directions does the scattering occur? What are the two main types of scattering that can be observed when light interacts with a sample, and how are they distinguished from each other? How do Rayleigh scattering and Raman scattering differ, and what are the key characteristics of each type of scattering? What factors contribute to Rayleigh scattering, and how does it affect the interaction of light with a transparent sample? What about Raman scattering? How does it occur, and in what way does it differ from Rayleigh scattering in terms of energy exchange between the light and the sample? How do these scattering phenomena help in understanding the material properties of the sample, and why is it important to differentiate between them in scientific analysis? What is Rayleigh scattering, and who is it named after? What is the significance of the British physicist Rayleigh in the context of this phenomenon? What other name is Rayleigh scattering known by, and why might it have this alternative name? How does Rayleigh scattering occur, and what role do particles play in this process?